So let's try another problem now that we kind of have the general method on how to solve these. And notice this one, both equations are given in this standard form. So if that's ever the case, I would recommend solving each of them for y, since we want to compare it to our slope-intercept form, y equals mx plus b. It's just easier to graph it in slope-intercept form rather than standard form where x and y are on the same side. So let's look at this first one. I'll do it in this pink color. We have minus 2x plus 2y equals minus 4. We're going to move the x's over here by adding 2x on each side. So 2y is 2x minus 4. And then dividing everything by 2 to cancel out the 2 on the y. You get that y is 1x, or just x, minus 2. And from here we can see the slope, the number attached to x, in this case would just be a 1, but we don't have to write that. So our slope is 1, or 1 over 1 if we write it as a fraction. And that way we can compare it to our rise over our run. And our y-intercept looks to be negative 2. If you plug in x is 0, you get back a y value of negative 2. So we can plot that y-intercept and then use the slope to find a second point. So let's do that right now. We want to plot it at 0 minus 2, and I'll just use the scale of 1 for each of these. So this is at 0 minus 2. And then we want to go up 1 over 1. Since our rise is positive, we will go up 1, and our run is always to the right 1. So up 1 over 1 brings us right there. We can do it again, up 1 over 1. And from here, we can just connect this line and extend it as far as we'd like. And at this point, let's try and look at the other one. So I'll use green for that. So we have 3x plus 3y equals minus 18. We want to get y by itself, so we're going to subtract 3x on each side. So 3y equals minus 3x minus 18. And then to get rid of the 3 attached to the y, since we just went y equals, we'll divide everything by 3. So that is just 1. So y is minus 3 over 3 would be negative 1, or minus x. And then 18 divided by 3 is 6. We have minus 6 there. M in this case would be negative 1. But again, we don't have to write the 1. So we have minus 1 over 1, comparing that to our rise over our run. And then b in this case, if you plug in x equals 0, y would just be negative 6. So this goes to the point 0 minus 6, and it has a negative slope. Now, let's actually plot this. So negative 6 would be, that's 3, 4, 5, 6 right here. And then it goes down 1 over 1. So you could plot it right here, but we ran out of dash marks, so I'm actually going to go the other way. So we can go up 1, left 1. If you do them both backwards, you can go the other way. So instead of going down 1, right 1, you can go up 1, left 1. So essentially put the negative on the run. So doing that, we get this point right here. Then we go up 1, left 1, again right there. And this one, again, is going to be a little bit difficult to tell exactly where they're going to intersect. But like I mentioned in the previous problem, the interactive grapher will help you figure out exactly where this point will be. But we know it's going to be at whole number values, and it looks to be at an x value of minus 2 and a y value of minus 4. So minus 2, minus 4, we think is the answer, and you'd be able to check it on the grapher. But without that, what you could do with the substitution method, since both of these equations are equal to y, you can just set their right-hand sides equal to each other. So minus x minus 6 equals x minus 2. And then from there, you get 2x equals negative 4. You can divide by the 2, and you do get an x value of negative 2. If you plug in negative 2 here, you get 2 minus 6, which is negative 4. So it does check out once you learn that other method.